Okay, Assalamualaikum and good afternoon to everyone. Okay, for the today presentation, I will take over. Okay, if I'm not mistaken, we have 4 group from CS2306A and 7 group, right, from the CS2595A. Is it true?
Yes, it is true.
Okay. Okay, we can start from the first group. Who volunteer want to present? You can
Hello.
Do you mind
start.
if I present first, please?
Hello.
Okay, you can.
All right.
Hello.
Thank you very much.
Malu tak? Boleh. Sekejap aku nak solat jap.
Okay, after one group finish, you can proceed to other group, okay? Don't wait, just proceed.
Koma. Sekejap.
Apa dengan barang ni, Mat?
Pakai akaun kita tu.
Babi. Akaun saya tu buat apa nak push gila.
Tak ada lah. Aku nak main com Aku malas main rated. Budak-budak main rated.
Are you? Hello? Is everything working now?
Okay, I can see your slide.
Sorry, everything was lagging for a second. So hopefully everything is working. All right, so I guess we can start. So, oops. Okay. Hopefully you can see everything and hear everything clearly. So hello and assalamualaikum. This is Adha, and my team and I will be showcasing the case study about the Illinois video gambling law. So our team consists of yours truly, followed by Mas Kistina, Nur Izlin, and Putri Shaidatul. So this is the overall view of the spatio-temporal visualization, where it uses a set of data with respect to space and time. In this case, the space is the state of Illinois of USA, and the time is from late of 2012 until late of 2018. So we have broken up the whole visualization into several parts. So the first one is the area graph, where it uses two qualitative variable and compares the quantitative value. The second one is similar to the area graph. However, it uses the line graph to compare two different values. The third one is the geographical map of the state of Illinois. And the last one is the legend. So the area map is to showcase the actual and the projected revenue projected by the lawmakers. The second is the number of video gambling terminals or companies and places to play. The map of Illinois of USA with terminals income by location. And the legend is to showcase the monthly terminal income by location. So the lighter the gradient color, the higher the income. The darker the gradient color, the lower the income. So based on the visualization and also additional data, we have extracted a few facts. The first one would be the state of Illinois legalized public video gambling. The purpose of the new law is to increase the state's financial revenue. The state revenue projected by lawmakers were rapidly increasing from late of 2012 until late of 2018. The actual state revenue from the video gambling has never reached its goal. Ultimately, the final revenue is 1.1 billion away from its projected value. Next one is the amount gambled by clients on the video gambling platform has increased immensely over the years and has surpassed both the projected and the actual revenue. The total amount gambled is 768% more than the projected revenue. Both the video gambling terminals and available locations with the video gambling platform has gradually increased over the years. So based on these facts, we can extract the knowledge. So the first one is the state of Illinois failed to meet their projected revenue. The amount gambled by clients are significantly higher. However, the state failed to gain a much similar income. The state of Illinois has allowed a high number of companies or terminal to operate their machines in any given location. The video gambling terminals are gaining a much higher revenue since the state is purchasing their service. So by approving the gambling law, Illinois did not manage to increase their overall financial income and has to pay more expenses to maintain the service. So moving on, we have the live visualization in action. So this is the start of the visual. So at the late of 2012, so when we hit play, it will evolve with time until the late of 2018. So as you can see here, the state revenue projected is slowly increasing. However, the actual state revenue is slowly catching up, but ultimately it did not manage to get the same projected value. And finally, it can be seen that there are 30,000 companies included in the state itself where they provide gambling services. So that is all from us. Thank you very much.
Okay, can I present next?
Sorry. I have booked it first.
Oh, okay.
Okay, thank you. Sorry, yeah. Wait, we have some technical problems. Sorry. Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we will present about spatial temporal visual, and our team name is Data Breakers. Okay, next. Before we proceed to our main case study, we will explain first about the meaning of spatial temporal visualization. Firstly, it is a visualization that concerns changes of information in space and time. It is used in data analysis when the data is collected across both space and time. In visualizing the spatial temporal data, most common method that is used is the combination of graph and times, maps and other. Highlighting, scaling, fisheye analogy, association updating, and dynamic change is the common technique that is used. The purpose of spatial temporal analysis are prediction and description. Okay, next. Okay, the title of our case study is Exploring Dynamic Biospatial Networks with Mosaic Matrices and Mirror Glyph. That the objective is to make scientific research of brain mouse. Okay, as we can see here, we have three pictures, which is in the left side is Rembrandt implements a visual approach for the analysis of spatial temporal brain network data. Two aggregate panels, which is at the A and B, encode the spatial distribution of neuron communities in mouse brains, overlaid with the medical imaging data. Mosaic metric views in the right side, which has the top 10 communities, is encode temporal changes in the selected subregion. We can see here at the top 10 communities, which is blue, orange, green. Red is the most used color in the visualization. Okay, next. Okay. On the left panel of A and B,
Watch me.
it shows a
Watch me.
mosaic
Watch
matrix views that encode temporal changes in the selected subregion. Okay, next. Above diagram, C and D shows the timeline views of
Mandan kan Amirul
active
Hafiz bin
nodes over
Johan
time,
terlalu
which is
sial.
we can see here at the
Kita
C.
terpaksa
We can
sama-sama
see
memanjatkan
we have
kesyukuran kehadrat ilahi.
8,387 active nodes at the time step of 50 time step, and the right side is
Ingat.
we have activation of 6,890 active nodes at 48 time steps. And at the below, we have two mirror glyph and Keviad diagrams that allow tracking dynamic changes over time at a single node level. Okay, next.
Kau ni bodoh. Kau buat
Okay.
teka-teki.
Okay, and the left side is a mirror glyph. It is show a node that
Kau
belong
orang kan.
predominantly and consistently to the green
Kau datang
community
kau orang.
as
Terus
its
cakap,
signal
"Do you know
increases
why
over
I
time.
always
We
be
can
the
see here we
number
have
one?
T1, T2,
Because
and
my name is
T3,
Amirul Hafiz bin
which is
Johan.
T1 that the node briefly visits the blue community, and T2 and T3 is two switching events that happen when the node joins the orange community, followed by the blue. And at the right side is the integration of temporal community characteristic into the brain slice of an edge mouse across 64 time steps. Okay, next. Okay, this is two Keviad diagrams. This is for the two nodes that reside most time in the green, respectively blue community. And the Keviad shapes indicate that the green node has longer activation duration, stays in particular communities for longer periods, and more consistent with its home community. Conversely, the blue node switches its home communities and visits other communities more often. Note the details of demand and index interaction dictated by the real estate constraints. Okay, next. Okay, and the last one is we have two mosaic matrices view. This is they have been displayed at the early at the slide that contains the mouse brain. This is representing two regions across different time period, which is at the picture of figure a region of 9 nodes across 33 time steps, while B, which is a region of 64 nodes across 12 time steps, which is the node in the top left corner of the mosaic matrix, initially part of the green community, then moved to the orange community, and finally joins the pink and blue communities in the last two steps. Okay, next.
Jom, jom, jom.
Okay, that's all from us, from the data breakers. Thank you so
Mano.
much. Okay, now we can proceed to the next group. Thank you.
Jangan ajak yang try hard je kan.
Rehat lah bodoh. Nah.
Okay.
Wainan.
Okay, I will now present a special temporal visualization for the topic emergence and spreading of disease and infections from 1998 till 2018. This is the global map of significant and new emerging infections in humans spread to new areas since 1998. And spatial temporal have features that consist of space, geographical area of the countries, and time features in a year from 1998 until 2018. And the visualization part that I want to show is first is the label. The arrow shows an indicator for each country with the type of disease of infection. The purpose of this arrow is to avoid misinformation when reading the graph. Next is the choropleth. The visualization uses a choropleth map to visualize the emergence and spreading of disease and infections from multiple countries. This type of graph is good to show the location, especially since the variables involve the countries. For the color, we use three different colors. The first one is the green color, which are newly identified emerging infection. Next to it is the red one, which is the disease is currently spreading to a new area. And lastly is the blue one, which is the combination of emerging infections and the diseases spread to that country.
Dia akan carry.
Okay, this is what I talked about just now.
Wah,
For the knowledge
lost
discovery,
connection.
disease emergence can be caused by interactions between microorganisms and human activities. New infections often result from several factors such as the population, climate condition, or human behavior. Multiple diseases have been identified throughout the history, such as virus infections, plague, and other diseases. This is the timeline that occurs from 1998 until 2018. For example, in 1998, we can conclude that Nipah virus appeared in Malaysia in 1998 and Ngari virus appeared in three countries, which is Somalia, Kenya, and Tanzania. Okay, the list goes on and on until 2018. Okay, for the findings, which country has the highest emergence of infections from 1998? China has the highest frequency of the emergence of infections by 9 infections from 1998 to 2018. Due to China being the country with the largest population, the chances of it being the source of infections is also quite large. Which disease have high spreading rate? Plague in Algeria in 2003 spread to Libya in 2009 in 6 years. Considering they are near to each other, it takes time for the disease to spread. In contrast, Lassa fever only took 2 to 3 years to spread between Mali, Ghana, Benin, and Togo. How many countries are affected by the spread of diseases in 1998 and till 2018? From that timeline, 9% out of 195 countries in the world are affected by the spreading of the disease. 7% of them are the potential source of the new disease, while 2% of them are both. Which country are the source and also affected by the spread of disease? There are only 3 countries that is only involved in the emerging of infection and disease spread, which is the United States of America, Saudi Arabia, and United Kingdom. Okay, that's it from us, and thank you, and please proceed to the another group.
Wait, kejap. Aku kena restart Valorant aku. Kesal aku tak jalan. Pundek tu.
Aduh, buat PC mahal-mahal. Cursor tak jalan.
Cursor tak jalan, bos.
Uish, nama macam sedap tu. Natasha. Lawa tak lawa, Bil.
Menarik tu. Tak betul. Santai.
Babi memainkan Nat je. Biadab babi. Nat dia memainkan hati kau.
Dah. Nama Nat ni lekat sial babi betul lah.
Mak lekat. Kau kenal tak Mak lekat?
Mak lekat tu.
Okay, next group.
Main
Who want to
ni.
present?
Bukan
Tak kenal.
Tell me about tonight when you were gone.
Lek aku minum air jap.
Oh, minum. Minum.
Hello, selamat siang. Selamat siang, selamat sore. Mari. Pi.
Mari puji memuji. Astagfirullah. Asal tak di-invite? Oh, terus party.
May I present?
Minum air pula. Kejap minum.
Pula.
Kejap teguk. Aduh.
Okay, you can.
Alright. Okay, Assalamualaikum and a very good evening. So, I'm from Data Now, and this is our presentation of spatial temporal. Before we start, this is the Data Now members. Me, myself, Natasha Aisha, Fatin Anis, Ifan Shafi, and Isaac Yunus. So here is an insight of spatial temporal visualization. A spatial temporal model is defined as a data model used to efficiently organize and manage temporal geographic datasets that are associated with additional attributes and with spatial and temporal semantics. There's more information later on of the spatial temporal. So this is the graph that we choose, which is the amaran hujan berterusan from Jabatan Meteorologi Malaysia.
So adik aku dah tidur malam.
And this is the explanation of the graph. So that's the title of the graph just now, and it indicates the overall idea of the visualization. The different gradient color will help in distinguishing the different intensity of the heavy rain. The legends and indicator for the visualization provide description according for each different color, and also there's the trend and timeline that shows visualization time related information. So for the knowledge of this graph, this diagram alerts the viewers regarding the intensity of continuous rain according to state across Malaysia. And the different colours, red is expected to be excessively continuous heavy rain. Orange is expected continuous heavy rain, and yellow as just expected continuous rain. So the diagram posted includes the rain forecast for the states across Malaysia, and it is expected to rain until 4th January. So there are some parts of the country that are suggested to beware of the weather condition only until 3rd of January 2022, and also the states affected by the rain are advised to take precaution that have been declared by the local authorities because of the flood that happened before. So another special temporalization that we can see is from the Ventus Sky website. This is a brief description of the visualization. It has an interactive visualization, a gradient color to interpret all of the attributes, the legends and indicator for the visualization, and also the trend and timeline. Thank you. Let's look at the Ventus Sky website. So this is the Ventus Sky for Malaysia. As you can see, this is the temperature. And on the right side, we can change the Fahrenheit to Celsius. So this is the legends. We can see that if it's white, it's very cool. And right now in Malaysia, it's something from 20 to 30 degrees Celsius. And there's a lot more other attributes such as perceived temperature, perception, weather, satellite, clouds, wind speed, wind gusts, air pressure, thunderstorm, humidity, wave, and also snow cover and air quality. So that's all from me. Thank you.
Ya ibadallah.
Itu esok.
Oh, esok. Ittaqullah.
Taklah main ni kali lah.
Wa iyyakum ittaqullah. Laqad fazal muttaqun.
Kau pun tak
Lepas tu,
pergi. Ini lebih sial betul.
ketubah-ketubahan. Selalu ketubah dua ni kan. Dua main point lah. Tiba-tiba pam. Hakimus solat. Wah, tu
Wah. Bunyi intellectual tu.
Dina.
Ini present betul lah ni? Allah, diamond.
Oh.
Sorry to Team Dato, we cannot see your slide.
Masuk B.
Ah,
Oh my god.
Oh
Ya.
my god.
Tembak ni tak?
Buat apa tu?
Ni pasu ni.
still cannot. Uh-uh.
Oi.
Sis, heal aku.
Oh, I can see your slide. Sekejap.
Masuk.
Masuk. Aku dah masuk lah. 60 beam, 60 beam.
Oh, maybe most of that can see your slide. Okay, maybe you can proceed. Maybe I have technical problem with my laptop.
Allah.
Okay, you can proceed.
My bad.
Okay,
Aku dash dia terjatuh bawah.
okay.
Ya. Okay, go. TP.
Allah.
Wah, dah penting sial lah.
TNT. Bapa jet tu laki sel dia headshot aku pakai.
Dah smoke ke?
Biar nasib tak baik je. Papi. Nice try.
Dan kalau kau nak smoke, kau kena bagi tahu aku tau. Sebab aku yang masuk kan.
Okay.
Kau bagi tahu aku kau smoke dekat choke point mana.
Kalau nak masuk stand dah entry lah.
Sebelum aku entry kau kena beritahu dulu. Kau smoke mana.
Boleh dah.
So aku boleh clear tempat yang
Chamber ni jigal lah. Nak aku tarik buka.
Sekejap.
Jack belum. Aku letak elbow dengan nak smoke lah.
Smoke.
Smoke.
$72 je.
Padu mat mirror.
Water.
Padu mat mirror.
Padu Mat Mirul.
Apa? Main slow.
Padu Mat Mirul. Tak cuak Madam kata tak nampak. Aku dah lah cuak mula-mula. Siap. Madam nak tegur apa.
Allah.
Apa Rena kita tahu ni?
Tahu semua orang nampak.
Assalamualaikum to all. My name is Tengku Nazmi. I'm as a representative from Team Data Professor will
Hello.
present our special temporal visualization on meal and traffic.
So I can entry. After Astra smoke.
For our graph, we use space-time cube map to show how phenomena change over time within a geographic space. Y-axis representing the time of the day, where the bottom is 12 in the morning and the top is at 11:59 at night.
Buat slide,
X and
tolong present
Z-axis
pula.
represent the coordinate for the location of the car. Figures are represented in the trajectory wall, in which line representing the same trajectory or same route from different time are stacked one upon another. For the figures, the color shade is obtained from color brewer scale, where high speed value is represented by the dark green shade, and low speed value is represented by the orange and red shade.
Aku tak mandi kan.
For the story of this graph, the visualization show the car traffic on a belt road surrounding the city in Milan, Italy for one day. As you can see from in the southeast of the map, or in the bottom left of the map, there is a slight traffic in the morning around 6:30 to 7:30 in the morning. There's also a slight traffic in the evening, where you can see at the top there is light green shade. That indicate the evening rush hour from 3:30 to 5. Lastly, from the graph, we can know that the average travel duration in the morning rush hour is around 15 to 25 minutes. And that's all from us. Thank you.
Termasuklah babi.
Rena takut.
Rena duduk belakang tu.
Okay, now I'll be presenting for special temporal visualization for our case study. I'm Hasha and I'm from Team Millennial. Okay, so what is special temporal visualization? It is a visualization that focuses on changes in information and in place and time. It's a tool for visualizing processes, displaying spatial and temporal analysis finding, and making decisions. The data for space can be zip codes, etc. or state, and the data for time can be seconds, minutes, hours, days, or year. For our case study, we'll be using state and years. The visualization is commonly in form of graph with time axis, maps, and so on. The technique used for the visualization are highlighting, scaling, fisheye technology, association, updating, and dynamic change. Some of the advantages is it can give us a broad perspective of activities or progresses, hence allowing evolution and general trend to be observed. It can also make the concept of time more accessible to non-expert user than typical visual depiction. Okay, so this is our graph. This is it is a distribution of food stamp issue in the 100 counties in North Carolina. Okay, so we can see here there's some stat, the blue stat, and the timeline is from 1970 and 2007. So it's a 3D visualization. Okay, so if we zoom in into the individual stat, it will look like this. Okay, so the shape is the individual polygonal disk for each year, starting from 1970, which is bottom here, and up until 2007. The Y or diameter is the normalized data for food stamp recipient. So the bigger the diameter, the more food stamp recipient it is. So the position is each stat is positioned on top of their corresponding geographical map. So this is the map. We have 9 regions in the North Carolina. So for each region there will be some stat. So the color here, it uses the blue gradient that indicate the number of food stamp recipients. Here we can see that the lighter the color, the less food stamp recipient, and the darker the blue color, the more the food recipient. And the thickness is constant. Next, some knowledge story from the visualization is the visualization is a spatial and temporal distribution of food stamp issue in the 100 counties in North Carolina through a nationwide program of the federal government of USA. The North Carolina Food and Nutrition Service, formerly Food Stamp, are available for all households with limited income and resource. From the graph, we can see that higher food stamp claim occur in the North region compared to other regions of North Carolina, since the size of these are more larger and more visible. So we can see here, this part have higher food stamp recipient because the stack have a white diameter and darker color. Next, Sand Hills and Southeast Coast region has larger number of limited resource and low-income households than Central Piedmont region because color of these are more significant and varied. So here you can see that there are different size, different color, different size compared to here. It is very not really different here. Okay, so since outlier exists and the vertical time exists, this indicates that something unusual happened, which affect the number of food stamp recipients at the central coast around 1975 till 1980. This here is the outlier that happened in that region. The timeline located above the chart shows that number of recipients elevated from year to year, which reveal the number of food stamps generated also increased. So from year to year, the start off with less data, and then there are more and more number of food stamp recipients. Okay, so that's all from us. Thank you.
Ada close race close. Cocok. Next one.
Kau masuk Mijam. Oh ya, ada.
Okay. Assalamualaikum. My name is Khadijah and my group member is Akiki and Najiha. Today I will present special temporal visualization, and the topic that we have chosen is population stress area in contiguous USA.
Oh, tak tahu nak cakap apa.
So this is the special temporal graph that we have chosen. So this graph shows the map of population stress areas in United States of America, where the legend is about the percentage of population changes in 1% decrease of land developability. As we can see at the bottom of the graph, there are 5 temporal colors which is start from red to blue. The red color indicate the count with
Nice. 84, let's go. 9 3 cast.
the count with faster increase of population than the decline of land developability, while the blue color indicates the slower population growth than the decline of land developability of a county. Next, the general trend that we got from this graph is special clusters of population grow faster than land developability decrease, or population decline slower than land developability increase. These population stress areas involve contiguous United States, which is the lower 48 states in North America, such as southeastern coast, Washington State, and North Texas. Among all of these counties, 8.7% of them indicate the high spatial clusters, which is the red color. These high spatial clusters are the hotspot where the population growth faster than the land developability decreases.
Kosong ah?
While the 12.1% of the counties in the contiguous United States had the low clusters, which is the blue color, where the population grew more slower than the land developability decreases. In summary, further development in low clusters areas such as the Midwest would have fewer population issues in sharing available land in the future, while the development in high clustered areas will be limited by the available and developable lands and the current population trends. That's all from me. Thank you.
Aduh. Sorry tu. Kau tidak menyangka terlalu cepat kematian semua.
Tadi aku dah masuk lah.
Rena, I can buy.
Aku dah masuk lah kat sini. Tengok tak ada orang. Orang semua kat city.
Tak apa.
Rena tak nak.
93.
No. Sorry tadi. Tadi aku tunggu Rena nak masuk. Nak blind ke apa patut sebab takut KJ duduk kat corner.
Hello and Assalamualaikum. So today I'm going to talk about the spatial temporal visualization. Okay, spatial temporal data, meaning that spatial refers to space and temporal refers to time. It is used in data analysis when collected data has both time and space features. It describes the phenomena that occurs in certain locations and times, such as movement of shipping vessels across geographic sea location. Spatial temporal data is commonly displayed using maps. So the spatial visual technique, it is easier to interpret the data if it's displayed on the maps. Feature of relevant objects are easily visualized through different maps. Some examples of maps are geographical maps, building plan maps, and website layouts. Some popular map-based visualizations are choropleth maps, heat maps, dot maps, and cartograms. So what we are doing is that the COVID-19 cases in Texas by the county in 2020. Okay, so as you can see on the left, this figure shows the confirmed cases per country in Texas. Each country here has different number of cases based on the type of color. The more darker it is, it represents counties with more cases, whereas lighter color represent countries with less confirmed cases. It is seen that the south of Texas here has more darker colors compared to north of Texas, whereas a lower confirmed cases are there. Next is the heat map. Okay, so this is the heat map of COVID-19 confirmed cases in Texas in the county. Heat maps are used to communicate numeric data by varying the underlying values. Heat maps can be used to represent large sets of spatial data. The warmer color, which is the color red, shows that the place is a hot spot for COVID-19 confirmed cases infection. The cold color, which is blue, shows that are in low in confirmed cases. However, we cannot determine the actual number.
Mementingkan rakan-rakan sebaya dulu.
Next, we have bubble map. In a bubble map, data source is properly represented with a bubble of variable. The size of the bubble represents the number of cases at a particular location. From the size of the bubble, one can infer how hard the data it represents is. Bubble maps can show several pieces of information in a single view by using different color for each type.
Padahal benda tu common angle tu.
The rest of the country has medium and small bubble size, which shows that the death cases of these counties are little. And the COVID-19 cases in counties with a bigger bubble size are probably higher than the county with a smaller bubble size. And this is the bubble map that I was talking about. The COVID-19 death cases in Texas by the county up until the 19th of September 2020. Again, the size of each bubble represents the number of death cases in different Texas counties until September 2020. So you guys can see here. So what we can conclude is that the number of confirmed cases of COVID-19 is increasing, and COVID-19 cases have been confirmed in almost 600k people across the country until 19 September of 2020. The number of verified COVID-19 cases in Dallas County is 77k with 118, and COVID-19 deaths in Dallas County are expected to reach 1,083 by September 19, 2023. So that's all from me. Thank you.
Ya, tak ada semua.
Bodoh. 117. Allah.
Masuk balik TP.
Ya Allah, chamber. Kenapa macam tu?
Elbow.
Elbow gitu.
Chamber, just watch elbow. I'll still watch CT.
Nice.
Nice one.
Puluh dua kan? Macam.
Dua kan?
Okay, the other group. Okay.
Positif sangat.
Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Abdullah bin Hamidun, and I will presenting spatial temporal visualization for Europe population growth, and my group is Datum Tech. Okay, this is the graph. It shows the map and the change in population from 2001 to 2011. Next.
Ramai tu.
Okay, for the visualization and graph, the form is similar to heat map, where it shows darker colors and lighter colors to show the difference in percentage of population change. The warmer color is decrease in population, while the colder color is increase in population. The color of the gradient shows the category of population changes in a good way. It manages to use less than 7 colors, which is easier for the user to understand. And the contrast of the colors for the categories are excellent, where it is easy to distinguish in the map. It also includes the time span from 2001 to 2011. It also pinpoints to show significance of the population in different cities for different countries in the Europe continent. Next, please. So for the findings, we can see the different city centers. It is unusual in Europe, where many city centers were historically densely populated with residential areas. Okay, next. For Ireland, we can see they focus on Northern Ireland and Republic of Ireland. Compared to neighboring England, Scotland and Wales, both the Republic of Ireland and Northern Ireland have experienced a much more significant population growth between 2001 and 2011, where we can see there's a lot of green, darker green spots compared to London. Okay, for Spain, we can see the overall Spain's population is in decline, where you can see the brown spots, However, many of the Spanish regions where growth can still be observed are located in the Catalonia in the east. Next. For France, we can see a few countries. France is the few countries in Europe with a growing population due to immigration and high fertility rate. There's a lot of people coming into Paris and France, so we can see a lot of darker spots scattered around the country, which
West Point.
shows an increase in
Kejap lah
population.
West Point. Biasa main sejam.
Meanwhile, in
main
Poland, we can
10
see
minit
there's a
je.
lot of no population change or decrease in population change, more than increase of population change. So a closer look at Poland's reveals how the country population growth has been concentrated around larger cities. So it makes sense for larger cities to have more population, although the east in general has seen a decline in inhabitants. Metropolitan areas have benefited, attracting more people.
Sekarang sebab dia boleh naik.
Next.
Aku wall depan sikit.
Yes, that's it from our team. Thank you.
Rina C. Oh, Rina seorang. Lihat Rina. Allah silap blok.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group Data Dive that will present Spatial Temporal Visualization. Okay, the title of our case study is Global Climate Fluctuations from 2002 to 2010. Next. Okay, we have two global climate fluctuation here, which is the change rate of global temperature, and next, the change rate of global precipitation. Okay, rates of change in global temperature and precipitation are visualized using choropleth maps. Choropleth map is the one of special visualization techniques. Different colors are used to represent the value or range of value of temperature and precipitation in various areas in a map. The color areas are patterned according to the values that are displayed. A common best practice for choropleth map is to use between 3 until 7 colors to allow us easy reading and understanding of the visualization. The legend of the bottom left is display the value label for each color. This map chosen visualize the rate of change in global temperature and precipitation using a darker color as a high value and brighter color as a low value. As we can see here in figure 1, the red areas indicate that the areas are warming due to high temperature, while lighter color areas show that area has low temperature from the year 2002 to 2010, where green color areas are indicating areas with the lowest temperatures. Next. Okay, in figure 2, blue color areas represent the areas with a high intensity of precipitation increase, while the areas with the yellow color shows that the rainfall in that areas are decreasing. Choropleth map have a limitation on seeing the statistical value. As we mentioned earlier, color and shading pattern are chosen according to range of statistical values. As a result, there is no way to actually see their exact value, but only range values. Okay, back to figure 1. Okay, now we want to present the knowledge. Okay, next. Okay. Okay, in the figure 1, the knowledge we can get is according to the visualization, it shows that the Earth is warming, but the temperature largely varies in different regions. The fastest rising temperatures are mainly distributed on the eastern side of the northern hemisphere by 0.193 degrees Celsius to 0.613 degrees Celsius, and the increase of the temperatures is obvious. On the west side of the northern hemisphere, the temperature has decreased significantly, with a temperature change rate range from negative 0.082 degrees Celsius and 0.99 degrees Celsius, whereas the east side of the southern hemisphere is cooling and the western side is warming. The air temperature change rate in the Asia continents, northern and southwest regions has been more than zero, with the majority of the northeast region having a temperature gradient between 0.193 degrees Celsius and 0.613 degrees Celsius. Temperatures are seen dropping a lot in China's northeast and Russia's central regions, with rates of change varying from negative 0.082 to 0.99 degrees Celsius. Last but not least, temperatures change rates in the northeastern section of North America were between 0.193 degrees Celsius, indicating a significant rise. Next. In figure 2, as we can see, the regional change rate of precipitation in most regions increase indistinctly, range from 0 to 10 millimeter, indicating that the global total precipitation rate is declining. As we can see from the visualization, the regions with the highest intensity of precipitation rise are mostly in the middle low latitude, while the intensity of precipitation increase in the middle high latitude is comparatively modest. Northeast Asia, South Asia, and Asia Minor Peninsula all have precipitation change rates greater than 0 millimeter. The precipitation change rate in the Gulf of Mexico coastal area and Eastern Europe range between negative 40 and negative 10 millimeter, with the decline being more noticeable and in other places. So from the graph, it can be seen that the rainfall in South America is increasing and variable, making it unpredictable. So that's all from us. Thank you.
Sekejap.
Kalau dia tak right click Rena.
Mau cuba lagi?
Okay. Thank you for the presentation. I don't have any questions, and overall, I think that's a very good presentation for all of the groups. You explain clearly on the choices of the graph and also knowledge that you get from the graph. Okay, do you have any questions? Okay, if you don't have any questions, we can end our session for today. And thank you again, and Assalamualaikum.
Waalaikumsalam.
Neon, ada tak main neon?